So this is kind of an introduction to EDI's Data Explorer. And DEX, we call it DEX for short. DEX has been out for a little while. It's kind of like kind of seeped out to the production site. It's been out there for a little while now. But one point I want to make about DEX is you can consider it to be somewhat in a beta release for probably a while yet, because there's still a lot of edge cases that we run into, and it's mostly because it's just a fairly complicated interaction between the EML metadata, the physical data itself, and then providing some review of that data. But let me go ahead, before we get into that, let me just go on a little bit of housekeeping here. So there is a code of conduct that we follow. In essence, that you can see there's a link here to our new website. It talks about our code of conduct. But in general, it's just to be mindful and respectful of others when we're in discussions. And yeah, it's just basically that point. But there's a lot more there you can look at. Also, you want to kind of remain muted during the presentations or discussions. But if you do have a question, don't hesitate to use the Zoom's raise the hand for questions. And that would be, well, I can't even see it now. It's gone off of my screen. And then, as Corinna noted, this presentation will be recorded. So just note that. In addition, there's EDI webinar information also available on our new website. And so that would be edirepository.org/webinar/webinar grid. And you can access that information there. And if you do have information for EDI, or questions, you can send, you can go to our new website, which is the edirepository.org, or send questions to either, kind of general questions to info@edirepository.org, or if they're more technically oriented type questions, you can send that to support@edirepository.org. And just a note that we have changed our domain name. You may also remember that we would have a longer domain name called environmentaldatainitiative.org. We shortened that up for both the email and the website, so just take note of that. Just as an introduction, I'm going to kind of give kind of the introduction to DEX itself, kind of an overview. But Roger Dahl, who is our DEX lead software developer, he's also on the call right now. He's going to actually provide the real-time kind of demonstration of using DEX from an actual data set from our repository. So he is the DEX lead software developer. So that's a photograph of him on the right side, more of the humanistic photographs that I've found. But he's also one of the PASTA software developers, so he's starting to learn the repository in great detail. And then just as an aside, he's also the author of Data One's generic member node. If you are familiar with Data One and how we interact as a member node with Data One, he is the principal architect and software developer of the generic member node, which is the Python software stack for the member nodes itself. Okay, so next slide. Data Explorer, DEX. So what is DEX? It's kind of an interactive table exploration tool that we've provided. One of the key aspects of it, in an informal way, we just say, it gives the end user, and not only just the end user, but I'll mention this here in a little bit, but a user kind of a gestalt about the data set itself. It gives them a little bit of ability to look at the data, kind of look at a quick analysis of the data, to do some filtering and subsets against tabular data. And specifically, this is tabular data that we're talking about. Right now, it's addressing primarily CSV style data sets, but it can also support tab delimited tabular data and things like that. But it gives the user basically insights to the data more so than you can, instead of having to download that data, open up some type of analytical tool, and then start analyzing it. At that point, it's just a quick tool. And we have to recognize that there are, certain limitations that we can provide as an online tool in this regard. But it does provide enough insight that, you can determine whether or not the data itself may be a fit for your use in your kind of downstream analyses. So we provide 3 different perspectives of tabular data. So the first is what we call the profile, and this is kind of a table statistical analysis. This is based on a third-party package that we use called Pandas Profiling. And then there's also the subset perspective, where a user can subset by a number of different ways, and we'll demonstrate that in real time. And then finally, there's a quick XY plotting capability that gives you an idea where you can plot an independent variable against multiple dependent variables. And as I mentioned earlier, it benefits really both the data creator and the data user. And you may ask, why does it benefit the data creator? Well, we found, even though DEX itself was kind of envisioned for the end user, what we found is that DEX can be very useful for a data creator, especially because it's available on the staging environment. And to look at your data to make sure what you're describing in your metadata actually matches the data itself. And as I said earlier, the data and metadata are intrinsically tied together. And if there are any errors in that description, it will show up in the data table views of this the Data Explorer. So it's really beneficial in that regard. So just a quick overview. The profile itself, it gives kind of an overview element where it looks at the number of variables or the columns in there. It looks at some general statistics about that, whether or not they're categorical, date, time, or numeric fields. It also gives you kind of a quick view. So it gives you the head and tail sample of that data table. So it gives you the first 10 rows of that data and the last 10 rows of that data. So you can kind of get a feel right away as to what that data looked like. And then it goes into a deeper analysis of each one of the columns or the variables within that table. And it does an analysis of that particular variable. And it plots it out depending on, histogram plots based on frequency, if they're numeric or categorical. And it has a lot of information here. And honestly, I'm overwhelmed when I look at this plot. And so this plot, this table view, this profile view, and often you find yourself having to go back to the original documentation for Panda profiles to actually kind of really get an understanding of what they're trying to tell you here. So that's the profile view. The next view is a subset view, and this is actually quite powerful because this subset view allows you to look at every row of those data, in this case, 10 at a time, but it shows you in detail that data. It also lets you know whether or not there is a mismatch within the actual data itself and how it's being described within the EML metadata. And then, in this particular view right here, you can actually select individual columns if you want to subset that data into a smaller subset. It also provides, this is kind of a NumPy query selection here. So if you're familiar with the Python NumPy application, there's ways to actually do some conditional queries against that data, so you can subset based on a nice functional query there. You can also do filters on date time. So you can look at a date column subset based on a start and end date. You can do things like row index subsets, so it makes that really nice. And then categorical filtering, you can actually select category, you can select multiple categories, and then it generates a subset download so that you can actually download that particular subset that you just identified. The nice thing about the download, not only does it download, it downloads as a zip file, but not only does it download just the table that you just subsetted, but it also provides you a regenerated EML document that describes that particular subset. And that, in general, gives you a lot of that detailed information that kind of comes from the original data set. And then it provides this JSON file, which is more of a kind of a specific view of how you did the query. So that's kind of the machine readable version of the actual filter query that you just executed. And then obviously you get the table itself. So that's kind of the power of the subset panel within the Data Explorer. And then finally, it does give a quick XY plot that you can actually look at. You can select a dependent variable, and then you can select multiple independent allows you to select a single independent variable and then multiple dependent variables. Then plot that up. We're using another Python package here called Bouquet. It's an interactive graph, so you can actually zoom around in the graph. You can select certain variables in there, and then you can just download this as a PNG image graphic. And I don't necessarily consider them to be publication quality graphics, but if you're just trying to generate a quick report, it does provide some nice content that you can actually use in that report. So it's a nice way of looking at that data. But most of all, and I just want to close out here, the one thing that we want to remember, we really are looking for feedback on the efficacy of using DEX. We want to make sure that it's usable as from your perspective, from customer perspective, from the user's perspective. And if you do see any issues or have any suggestions, don't hesitate to send us an email to the support@edirepository.org, or just drop us a line on Slack or something like that. So with that in mind, that's the quick overview. I'm going to transition. I'm going to stop sharing here, and I'm going to let Roger then go ahead and take over the presentation and show you a little bit more real-time interaction with DEX. So take it away, Roger.
All right. So the kind of the entryway to DEX is through the data package landing page. So when you arrive at the landing page for a data package, if there are any currently any CSV files in that data package, then they get this Explore Data button that will bring you over to DEX. And when you click that button, if the data package is, if it's the first time that anyone opens that data package in DEX, then you will have to wait for the profile, the pandas profile, to be generated. As usually, so that one took like 15 seconds. And then you get into this profile page that we were just looking at. So in this profile page, there are, as Mark mentioned, there are just a lot of statistical information about the data that that we're hoping is helpful. And so it does a pretty thorough analysis. For instance, it shows you how much correlation there are between various fields in the CSV, and it shows you then for each field in the CSV all this statistical information, like so. And we are going to link in a link to some documentation for this, which is online. So there is some online documentation for pandas profiling that at least briefly describes what's actually going on in all of these fields, all of these separate analysis that it's providing. And I'm not sure if there's much more to say about that, Mark. What do you think?
I think that covers it probably right now, Roger. I mean, I think, I'm just, if Marina or Miguel, you have any questions, or Colin, if you want to chime in at all. Again, one of the things we're trying to ascertain is, like I said, how useful are these perspectives for DEX? Now, obviously, I think the subset perspective is probably one of the most critical parts of DEX, but we could certainly address issues with like panda profiling. If it's overcomplicated, does it provide you the right amount of information? Just let us know. We're really looking for that type of feedback at this point.
And even this this information that we are showing is actually not all of the information that we could be showing. There is more, there are more statistical information is available, but it takes extra time to generate. So we, yeah, so we're looking for feedback there. So I'll just move on then to the subset page, which is up here. And so in the subset page, the basic principle is that you can imagine that you start out with a complete, the complete table at the top, and then you can apply these filters, and each of these filters can remove some of the rows or columns from the original CSV. And by the time you get through all of these filters, whatever is left after all the filtering is what you get when you click on this final download button. So if we move back to the top, the filter by query filter is the most complex filter. It has kind of a lot going on in it. You can use these checkboxes in the columns here to select to completely remove columns of the table from your final filtered set. And it will show you, so this is where so there's a close integration between what is showing in these filters and how the table is described in the corresponding EML document. And if, like here, you get these exclamation marks, what it means is that that DEX was not able to interpret the values in the actual table cells as according to the EML document. And for instance, in this particular one, it turns out that the EML document has date format descriptions that are not exactly matching the dates and times as they are appearing in these cells, and so that's why they get these exclamation marks. And when a cell gets an exclamation mark, it just means that it will get ignored in the filtering. We will bring the data through, but we can't actually process it at that point. So down here in the query field is where you can type out a query that is or to remove rows that don't fit the data that you're interested in. One use case for this is if there is a large data set that contains data for many previous years, and maybe you're only interested in the last few previous years, then you can use this filter to say that you want only, for instance, years after 2020, for instance. So to use this query filter, you just start, well, you just start typing a query, and to find out exactly what the syntax is for the query, there are two links up here that you can go to read about this query syntax. But for basic cases, it's pretty simple. So say, for instance, this snorkel transect number over here that has numbers 2 and 1. Let's say that you're only interested in 2 or higher. Then you can do something like this. So you can then type snorkel transect number higher or equal to 2. And I guess all right. So in this particular case, what we have in the EML is a declaration of this field that says that it's not numeric, it's a categorical, which means that I have to actually use a specific equality to select on that field. So you may have noticed that while I was typing, there were some status messages coming up down here. And basically what happens is that while you're typing, the if you pause for a little while, then the query gets executed. And if the query is not completed at that time, you're still typing, then you will typically get an error out just saying that that the query is not complete yet. So as I'm typing here, I'm getting these incomplete query errors, and then as I finish and just stop typing, it successfully runs the query, and it will tell you then that the query is okay, and it will tell you what the result is. So in this particular case, the full data table has 6,778 rows, and adding this query reduced that down to 1469 rows. So when you're done with this query, you can move on and apply further filtering. So to apply a filter by time period, you will select one of the fields that contain a date time. And this depends also on what's declared in the EML. So for a field to come up as filterable here in this filter, it has to be declared in the EML document as containing date times. For this particular table, there is only one field that has been declared that way. And so when you select that, it will initially just give you the full range that was found, the full range of dates that was found in that field. And then you can narrow that down to select what you need. So, and then the same thing here, if you want to select only a section of the table, you specify the first and last rows of that section here. And it gives you a little bit of feedback in that, you know, if you say that you want only rows after row 100 or starting at 100, you type in 100 here, and then it will give you a bit of feedback telling you what that exactly what that did to your initial table. And same story for a filter by category. So this depends on EML. That in the EML document, these columns have been declared as categorical, and when so the categorical columns will then show up here, and you can select a categorical column, and then you can select one or more of the categories that were found in that column. So this particular column is a site ID. It contains looks like 7 or so different site IDs, and you can then select one or more of those to narrow that down, and then you can keep selecting the on other categorical columns and narrow it down like that. And as long as there are more columns to choose and more filters that you can do, it will keep opening up these new sections for you to fill in. And if you change your mind and you remove some of these, and then it just closes down. It will close up the columns when they are no longer in use. And at the end, so down here, like say we have selected something like this, it again gives you a bit of feedback saying exactly what it is that you've done to your, what this filter will do to your result. And then you just go ahead when you're happy with what you have in here, you just go ahead and click the download button, and you get a zip file. And in the zip file, there are three files, and they are named after the name of the table. So up here, we had the name of the table was Snorkel All CSV, and so we have that name here, Snorkel All CSV. And this CSV file then contains the filtered result. And this EML file contains the an EML file that is based on the original EML file for the whole package, but it is it has been it's limited to contain only information for this specific CSV file that we filtered, and it contains a bit of extra information that is relevant or adjusted to match only this filtered CSV. And then at the end, there is this JSON file, which is the machine readable file for that describes how what was filtered. And the thought behind this one is that it describes your provenance. And so if you have something where you want to provide a reproducible result, or provide some way to automatically reproduce the filtered CSV, then this JSON file contains all of the information that was required for that.
Roger, Miguel has a question, and the question is if there are like the parents in the attribute name or the column name, how do you escape those?
Parents in the column name, I'm guessing you can escape those by quoting your column name. So in this example here, I think if you add quotes, I think it's going to let you do that. Let's see. So here, and sorry, maybe single quotes. So let's see.
I'm trying it. It's not working for me.
Not single quotes either.
Yeah, nope.
How about if you do a backslash before the parents? See. So for instance,
No.
if I no, then I am not sure
Gotta be a way to do it. One would
Yeah, I
think.
did think there is a way.
We'll figure it out and let you know, Miguel.
Yeah, I'll take a look at these examples and see if there's a way. All right, so also worth mentioning is that in all of these pages, in profile, subset, plot, you can, if you click on the table name down here, you will actually, it triggers a download of the complete CSV if you complete an unfiltered CSV as well. And the same for, you can also click on this package ID directly. So that's probably pretty much does it for the filtering, I think. Do you think, Mark?
Unless there are any questions from additional questions from Miguel or Marina.
Not at the moment. I just tried it out on one of our data sets and it seemed to be working okay, but we didn't have anything like special characters in the column's name or anything like that. So I'd probably want to poke around at it some more before I come up with questions.
Sounds
Can
good.
we just see what one of the JSON file looks like?
Sure. So let me try and pull one of those up. So it's a pretty cryptic file, but it has a key for each of the main filters, and this cat map is categorical mapping, and that is this filter by category one. And so what we had chosen there was, so what it's showing is that we had added these two values for this category and this value for this category that we were filtering on. And a column filter, all of these values for set to true, is representation of all of these checkboxes up here where you can choose which columns to include in the final filtered CSV.
Okay.
Date filter is just the dates that were chosen and the column name that filters on. And then the query filters show the query that were typed in. And the row filter shows the rows that we filtered on. So that is where I said that we would start on row 100, and it automatically put in the final ending rows because we didn't provide one. So it just will filter from row 100 and all the way to the end when it sees that. And then
Cool.
if we open up the CSV, we will see that this snorkel transact number that we filter on, those will all be 2 now, and there won't be any indexes in here lower than 100 because we filtered on that, and so.
Thanks.
All right. So then I can just move on to the plot. So the plot is it's a simple XY plotter where you can also enable lines. So you can plot just points, or you can plot lines. And you first select your independent value, which can be any numerical column and any date time series column. So for instance, here it shows this the date column that we saw before, that we filtered on as a time series starting at 2014 and ending in 2022. And that was the only time series column that it had in this CSV. The other columns are numerical columns down here. And any of the categorical columns just don't show up here because you can't select those as independent values. So if we select the date as our independent value, and then select, for instance, the one of these, such as the visibility value, and plot on that, we get something like this. And what we notice here is that so it has the date column down here on the axis, showing that it starts at 2014, ends in 2022. And it's also showing that there's no data for 2018. And if you go back and actually look at the description for this the data set, it mentions that there is no data for that time. And so you can add lines if you like. I put that one up there. And so when you got a result like this, so you see the lines are actually not, they're going across as well as up and down. It's because it uses the actual order of the rows in the CSV to plot these out. And so the lines actually represent the order of the CSV, and so this for the lines to actually come out as you might expect in this CSV, the whole table would have to be ordered by the date column. So another thing you can do in here is you can check for correlation. For instance, the DO, which is dissolved oxygen. If you want to see if there's a correlation between dissolved oxygen and turbidity, like down here, then you can choose dissolved oxygen milligrams per liter as your first value, and then turbidity as your other, and plot that out. I'll just turn off the lines, and you can see if there is a correlation. And as Mark mentioned, if you want to save the result, there is a little save button here, and you can also move around in this plot, and you can zoom in as well. So you can select this button to be able to use the scroll button on the mouse to zoom in on an area of the plot. And you can keep adding as many independent values as you like from the set here. So I'm plotting them out, and it will automatically assign various symbols to each of these. So are there Any questions related to the plotter?
Is scatter plots the only option available?
It is for now. Which other plots would you like to see?
Some like bar plots or histograms might be useful.
Mhm. Yes, we have considered both of those, especially we've been considering a histogram. We think would be very useful. As it is, if you go to the profile, there is kind of a rough histograms that you get for the columns down here. So let's see. For instance, the date column that we had before, is showing which dates are in use. And this is one place you can see that there was no data for 2018 for this result set. Scroll down to other values down here, like this dissolved oxygen histogram down here. Looks like this.
Okay, thank you.
Sure. And then we also have this final button, this EML button, which actually brings you back out of DEX and back into Pasta, where you can view a rendered view of the EML document itself, and either in a sort of rendered view or in the raw XML view.
So Roger, you may want to mention also on the upper right-hand corner, you can download the full original table off of the snorkel, where it has the snorkel _all CSV.
Yeah, that button is here. You can, if you click here, it just triggers a download of that CSV. It pulls it out of the package that I was in and gives you just this one CSV file. And when you click on this link up here, it brings you back to the landing page for the package itself.
Roger,
And,
if you go back to the subset.
Yeah.
I don't know, do you want to describe how the debug function works in this screen? It's helpful at times, but it could be pretty overwhelming with the amount of details in there.
Sure. So if you click on this link up here, where the DEX Data Explorer link, it brings you into a page where there are a couple of utilities here. If you know the data package ID, you can actually just put it in here directly and click on open without having to find it in a data download. In the package landing page. And the other function that is in here is that you can turn on what we call the debug panel. And so you click on enable debug panel here. If you then go back to for instance, the subset page, and you refresh that, you get the subset like before down here, but at the top you get this new panel that contains all of the data that DEX is working from. And so it shows a lot of information down here that is useful if you're trying, especially if you're trying to find out why the information that's showing up is not as you would expect. Like if you, especially if you are the EML author, you might be able to use this to adjust your EML so that the data package works better in DEX.
So a good example is those warnings that are on the start and end times. So if you look at the actual interpretation of that particular column, so you'd have to go back up to the top of that debug panel.
So if we're at the very top of the debug panel, this table up here shows what we know, or some of the fundamental stuff that we know about these columns. And if we scroll out to the start time that it's showing the exclamation mark for, which is down here, we'll see that we pulled from the EML document, we pulled this date and time formatting information. And when we look at the actual cell values in the CSV, it does not match up because the format value here shows that there's a space between the date and the time, while in actuality there is a T between those. And it also does not show anything after the time, while we actually have time zone information after the time. This is Z, which means that it's a UTC. So so then, you know, so if you use that, you can see easier what you need to adjust in the EML document for this data to match up. And also at the very bottom of this document, there is there are these fragments of XML that are pulled from the EML that show exactly what we had to work with. So for each of the columns. So you know, there's a project ID, which is the first column here, how it actually looks in the EML document. And when and if you're you no longer need this debug panel, you can disable it from here, or you can go back into this, the main the page that contains those settings, and disable it there. So I'll just turn it off here. So I think that pretty much covers it.